In this lesson, we're going to look at the tan graph. Now, you'll notice I've said tan graph and not wave. The last trigonometric function to look at doesn't create a wave, and for that reason, it's not really applicable in real life. So it doesn't create sound waves and light waves and so on. So we don't really explore it too much. We show it and have a think about it a wee bit, but no, don't explore it as much as the sine wave and the cosine wave because they're more applicable in electricity and things we use. So the tan graph, let's have a look at it. So I suppose we should really relate it to the triangles first, or all the different angles. So 1, 2, 3, 4, all the way up to 89 again. Now, what you'll notice straight away, hopefully, is that when we look at these numbers and we go down here, we can see they're going above 1. So there's tan 16, 17, 18, 19, all the way up to 35, and so on. So down, keep going. When we're at tan 70, it's 2.74, and then we get to tan 80, we're at 5 point something. It's a bit strange at the end here. When we get to 88 and 89, we're way up at 57.29. Now, when you put in tan 90, a strange thing happens. If I do it in the calculator here, if I put 90 and hit tan, it says invalid input. You can't actually get an answer to it. If you try it in your calculator, there'll be an error. So you can't actually do tan 90. But you can definitely do tan 91. I'll try that. Well, that's given me an answer. And the other strange thing is, you can do tan of 89 point something. And I'll show you that. Let's go for tan 89.9. Let's take the tan of that. Oh, it's 572. Let's go 89.999. Oh, the number's getting really big now, so it's 57,000. Let's go 89 point, let's fill the calculator up. Not quite 90, but I'm getting very, very close to it. And you can huge numbers. I mean, that's millions, billions, trillions, quadrillions, huge numbers. And it goes on and on. The more nines you put there, then the bigger number you're going to get here. And there is a reason for that, and we'll have a wee look at it. Right, so I'm now going to go back to this idea here of using the triangles to plot the graph, the tan graph. Now, this is going to look a wee bit different. It's not a wave, and you'll see the numbers didn't really look like a wave there. So let's see what's going on. So now tan is opposite over adjacent, so it's the opposite side of the triangle over the adjacent side of the triangle. So there's tan of 14, so it's opposite over adjacent. We're getting 0.25. That's that divided by that. If we continue all the way up here, we're getting 6.6 over 8.2, and carry on, all the way up. Once we get up to 60, we've got 9.4 divided 4.7, and then once we're up here, we're at 10.2 divided by 2.3. It's going up quite steep now. And once we get up here, it's going really steep. We've got 10.4 divided by 1.1. So that's up at 10. And then what happens here is you're going to end up with 10.5 over 0 point something, which is actually, when you're dividing by something less than 1, you're actually multiplying. So you end up with really, look at the size of that number, really huge numbers. Now, you can't actually put it to 0 because in maths we can't divide by 0. That's saying it there, but that'll be 0.0 something or other. But we can't divide by 0. So there's no answer for dividing by 0. So tan 90 doesn't exist. Now, when you get to tan 91, we start having a negative value here. If you're thinking of the coordinate grid, so we've got negative values. So we're starting way down here, and we're getting a negative value here. Remember, it's opposite over adjacent. Negative value is getting bigger and bigger and bigger, and then we're getting 0 here. Okay, and then down here, what we have is opposite side over adjacent. These are both negative values, so it creates positive going up here. So positive, positive, positive. And then what's going to happen again, the bottom of the triangle is going to go towards 0 again, so it's going to get really, really big. It's repeating itself basically. And then you can't divide by 0, so tan 270 doesn't exist. I know it's saying it up here, but it'll be 0.00 something. It won't just be exactly 0. And then we're here, we're at negative, and then back to the start. And we could keep going and it would continue. Now what you should notice here is the graph is starting to repeat itself here. It's doing the same thing at this point, 180. Before it was starting to repeat itself at 360, but this graph's a bit different. It starts repeating itself at 180 degrees. Okay, so let's try and draw our table out and do it ourselves, okay? So we'll draw this here, and I'll give you a time to fill it in. Just type these numbers into your calculator and fill them in. Okay, so hopefully you paused the video there, and I'll reveal the values. So tan 0, if you type in your calculator, 0, 0.58 for 30, 1.73, 89 gives 57.3. If you put 89 point something, you'll get answers. Tan 90 doesn't exist. You can go to tan 91, which will give you negative 57.3, and then so on. And these are the answers you're going to get. Again, tan 70 doesn't exist. Now the tan graph is a bit of a strange one. So we've got this thing here, which is a vertical asymptote. Now I wouldn't worry too much about that, but a vertical asymptote is basically an imaginary line in the graph where the graph approaches that line but never quite touches it. Here's the definition here. An asymptote is a line that a curve approaches as it heads towards infinity. The graph was going to infinity at this point. As we put 89.999, it was getting really, really, really big, but it will never quite get there. It doesn't touch the asymptote. Okay, so if you were plotting the values, you should end up with a graph like this, going along and then up really high. You could get close to the line. This is a computer generated image, but it would get really close to the line, but wouldn't actually touch it, and then it starts again down here. So you can see here the period's 180 degrees because it starts to repeat itself at 180. And if you're talking about how high the graph goes, you can't define that. It's infinity. It goes off to infinity. So the amplitude is undefined for this one. Okay, you can draw it quickly. I don't know if I would put the 6 boxes to 1 actually there and down to -1. I would maybe push a wee 1 here, and then I would go for 90. I'd put your asymptotes in. The vertical asymptote happens at 90 and 270. So when you're drawing your graph, just go along a bit and then up. 1 would probably appear down here, not up there. That was a mistake to have up there. So down here somewhere would be 1. Up there is more like 57 and so on. And then it's almost symmetrical in some ways, kind of rotational symmetry, and it goes up and back to there. And then it starts again, and it would continue to go all the way up, and then it would finish off by going up there. So that's really 2 tan graphs up to 360. So remember, the period is 180, the amplitude is undefined. Okay, I would try the exercise in the book.